Good day everyone. For today's lesson, we're gonna talk about arithmetic progression or arithmetic sequence. So let's start. Let me give you first the definition of arithmetic progression or arithmetic sequence. It says here, in mathematics, an arithmetic progression or arithmetic sequence is a sequence of numbers such that the difference between the consecutive terms is constant. The difference here means the second minus the first, or you can subtract third minus the second term. It means that you can subtract any consecutive terms, but you have to consider the fact that you can only subtract succeeding term minus the previous term. For instance, the sequence 5, 7, 9, 11, 13, and 15 is an arithmetic progression. So to get the common difference, you can subtract second term minus the first term. So you have 7 minus 5 is equals to 2. Or you can subtract any consecutive term but only the succeeding term minus the previous term. So now, let me give you the objectives of our lesson today. Number 1 is distinguish sequence in arithmetic progressions and solve for unknown using the last term formula. And solve practical problems using arithmetic progression formula. Now I have here the common terminologies of the lesson this morning. A sequence is a set of numbers with a definite order or arrangements and form according to a definite rule. So there is always a ruling in terms of sequence of a number. It can be divisible by 2, it can be adding by 3, it can be subtracting by 3. It depends of the rule that it has. The numbers in a given sequence are called terms. So each numbers in a sequence, we call it terms. An arithmetic progression is a sequence of numbers in which each terms after the first term is by adding the fixed number to the preceding term, called common difference. For example, we have -1, 2, 5, and 8. So to get the common difference is we just have to subtract a succeeding term minus the previous term. When you subtract 2 minus -1, the answer is equals to 3. Another example here is the sequence 4, 1, -2, and -5. As you can see, the sequence is descending. To give you an idea that the common difference will be a negative number. So just pick two consecutive numbers. So let's have 1 minus 4 is equals to -3. Now in my next slide, we're trying to derive the arithmetic progression formula. So let's say if A denotes the first term, okay, of an arithmetic progression, and D is for a common difference, then the terms of arithmetic progressions are first term A, second term would be A plus D, because we know that to get the next term, we just add the term in the previous and the common difference. So the second term would be A plus D, and the next is A plus 2D. Next is we have A plus 3D. So now we can say that to find the next term, we can use the formula of A plus the quantity of n minus 1 times D. It means that you can use this formula to find any terms in the sequence. So let me give you an example to prove that. Okay, so what is asked in the problem right now is what would be the number after 11. First thing you have to do is you have to know if the sequence that you have is an arithmetic sequence. To do that, you have to check if you have a common difference or a common number in each term to the next term. Next is determine the common difference. You can subtract each number from the number following it in the sequence. For example, let us denote first that D will be our common difference. So D is equals to A sub 2 minus A sub 1. So our A sub 2 is equals to 5 minus A sub 1 equals to 3. So 5 minus 3 is equals to. That is our common difference. So going back to the problem, so we are asked to get the A sub 6, the sixth term. Okay, since we have our common difference, what we need to do now to get the sixth term is we have to use the first term. The first term, which is 3, should be added by 2 to get the second term. Add by 2 again to get the third term, so on and so forth, to reach the sixth term. So you need 5 2's plus the first term to reach the sixth term. Okay, so by using this equation, A sub 6 is equals to A sub 1 plus 5 times 2. Substituting A sub 1, which is 3, so we have A sub 6 is equals to 3 plus 5 times 2. So 5 times 2 is equals to 10 plus 3, you have 13. Therefore, our A sub 6 is equals to 13. Okay, to sum up the formula, so the formula for arithmetic progression is A sub n is equals to A sub 1 plus n minus 1 times D, where A sub n is our last term, A sub 1 would be our first term, n would be our nth term, and D is our common difference. So now let's have an examples on arithmetic sequence. By the way, let's state the formula again. We have
is equals to A sub 1 plus the quantity of n minus 1 times D.
Number one problem is you have to find the 10th term of the arithmetic progression or arithmetic sequence 10, 7, 4, so and so forth. The first thing we have to do is we have to find the value of the variable in our formula. So first is you have to find the common difference. So to get the common difference is we have to find the difference of A sub 2 minus A sub 1. So we have 7 minus 10 is equals to negative 3. So our common difference is negative 3. Next is the value of our A sub 1, which is equals to 10, and our nth term, which is 10 also, okay, because we're looking for the 10th term. So n is equals to 10. So let us now find the 10th term of the arithmetic progression of 10, 7, 4, so and so forth. So we just have to substitute our given, which is A sub 10 is equals to 10 plus the quantity of n minus 1, which is 10 minus 1 times the common difference, which is negative. Let us now simplify the equation. We have A sub 10 is equals to 10 plus the quantity of 10 minus 1, which is 9 times negative 3. So we have 10 plus negative 27. So 10 minus negative 27 is equals to negative 17. Therefore, the 10th term of our arithmetic progression, which is 10, 7, 4, is equals to negative 17. Okay, so let's have our last example. In arithmetic sequence, given that A sub 1 is equals to 2, and our A sub 5 or our last term is equals to 14. Find the common difference. So here in the last problem, we are asked to find the common difference, but the problem is we don't have any sequence of number to subtract to get our common difference. So what we're going to do is we have to use the formula of arithmetic sequence which is a sub n, is equals to a sub 1 plus the quantity of n minus 1 times t. And then let's try to substitute everything that we have in the problem to get our common difference. So what we can use in our problem is our a sub 5, which is equals to 14. That would be also our last term, or a sub n equals to 14. And our nth term is equals to 5. Okay, and then let's try to find the common difference. Okay, by the way, we have our a sub 1 also, which is equals to 2. By using the formula, which is a sub n is equals to a sub 1 plus n minus 1 times t, we just have to substitute our given. We have our last term, which is 14, is equals to a sub 1, which is 2, plus the quantity of n minus 1, which is 5 minus 4, times the common difference. Since we don't have common difference, we just write letter D. Okay? So, simplifying this equation, we have 14 is equals to 2, plus the quantity of 5 minus 1 is 4, times D, we have 4D. So, this time we have to combine like terms. So, we have to transpose 2 to the other side. So, it would be 14 minus 2 equals 4D. Then we have 14 minus 2 is equals 4D. That would be 12 is equals to 4D. Then we only need a common difference, so we have to eliminate 4 by dividing both sides by 4. So 12 divided by 4 is equals to 3. So therefore, the common difference is equals to 3. So to check if your common difference is correct, you have to use the first term. And then, by using the first term, you have to add your common difference to it to get your second term. Add again the common difference to get your third term. Add again to get your fourth term. Add again to reach your fifth term. Make sure that your fifth term is equals to 14 so that your answer is correct. So that's it. That's the end of the lesson. I hope you learned something today. God bless, keep safe, and see you next meeting. Bye-bye.